Okay, this is video number 4, and we are going to try to move through this one quickly. Believe it or not, this is probably the 5th or 6th time I have tried to do this video, and I want to make it as clear as possible for you, and so I keep redoing it for that reason. And also, my phone keeps running out of storage, so I'm going to need to get through it more quickly than I have the other times. But we're going to be applying our triangle inequality theorem to this example. So this one, we are just doing a different application of the theorem, and we're finding side lengths. This problem tells us that we have a triangle with side lengths of 11 and 6. And in the problem, they want to know what the range of possible lengths for the third side is, or are, sorry. Now, please notice that they don't say solve for the third side. They say what's the range of possible answers from smallest to greatest. So let's look at that. Let's look at how they did that. Well, they did it by solving inequalities. Remember that an inequality is an equation like this that actually does not have an equal sign. Instead, it has a greater than or less than sign. So that's what we're going to be using, and we will treat it just like an equation. Let's let S represent the missing side, and we are just going to apply the theorem by making sure that each set of two sides is longer than the third side. So we're going to say x plus 6 needs to be greater than 11. We're going to say 11 plus s needs to be greater than 6. And we're going to say 6 plus 11 needs to be greater than the side. So let's look at that. Y'all, I'm also a little on the tired side, so if I am making verbal mistakes, I apologize. Hopefully you will know what I meant to say, so just bear with me. But we're going to start with the side plus 6 should be greater than 11. Exactly what we did. Side plus 6 is greater than 11. And remember, we're going to solve this like an equation. We're going to isolate the variable. That means we leave s alone on the left side. And then we're going to subtract 6 from both sides. So 11 minus 6 is a 5. And this answer is s is greater than 5. Now let's look at the next one. S plus 11 is greater than 6, and it should be. It has to be in order for this triangle to work. 11 plus s, this side, must be greater than 6. Well, this time we already know it's going to be because the 11 is already greater than the 6. So first of all, we're not real concerned about this one, and second of all, when we solve it, it has a negative number, yet we cannot have a negative side. So we're going to cross through the one with the negative answer. And lastly, we're going to look at the one that says 11 plus 6 must also be greater than the side. So we're going to solve for our variable, and 6 plus 11 is 17, and s must be less than 17. Notice the s is on the less than side this time. So what this problem tells us is that s, as you'll see in the middle right here, must be greater than 5. S is greater than 5. And s must be less than 17 because this one tells us s is less than 17. Now let's look at our triangle up here and see if that works. What if we put in a 6? Because 6 is greater than 5. So we're putting in a 6 for the s, and we're saying 6 is greater than 5. If we put in a 6 right here, does it work? Is 6 plus 6 greater than 11? Yes, because it's 12. Okay, what if we didn't obey that s must be greater than 5? What if we said s could be 5? Well, no, that won't work because 5 plus 6 is 11. Then it's not greater than the third side, and as you saw before, our triangle won't close. All right, so we know that doesn't work and that this was accurate. S has to be greater than 5. Let's look at s is less than 17. Is that true? Well, let's try 16. Does that work? 11 plus 6 is 17, and yes, in fact, that is bigger than 16, and so this triangle can close. It can make a true triangle. But what if we tried 17 there? It says s has to be less than 17, but let's just try the 17. Well, that will not work because then it's equal to what these sides are, and I showed you with the straws that that just cannot be. So hopefully you understand that. Come back to this, reread through it, and use the videos in your lesson as well on the homework. That will help clarify this if you're a little confused. And I'm going to do one more quick video for you. So that'll be number 5.